All right, everybody. So this lesson on multiplying polynomials, I have the answer key here. Big thing that I just wanted to make sure that you guys remembered is when you have two binomials, you have to distribute not only that first term, but you have to distribute that second term and then combine like terms if it's possible. So if you remember you were just doing odds, you can go ahead and check these answers quickly. You will see a question like this rectangle problem somewhere on a quiz or a test. So once again, write a polynomial that represents the area of the rectangle. If you have both of the dimensions, all you have to do is multiply length times width and distribute. Let's see here. For day 2, this one was a little bit more complicated. So when you're multiplying multiple monomials, you're going to multiply each constant. So half of 6 is 3, and 3 times 2 is 6. And then you're going to add all of your exponents together to get 6. But yeah, 1/4 times 1/4 is 1/16. Let's see, what else? So remember, you're going to add your exponents. I, on number 5, did not switch the order. So this is 5th degree and this is 6th. I am not in standard form there, so just fix that for me. So yeah, I'm just showing you the answers. Let me know if you guys have questions on any of this stuff. Feel free to email me, but like I said, you will see a question like the rectangle problem somewhere, so making sure you know what the dimensions are, and the area is length times width. So anyway, so triangular prism. So once again, a lot of this stuff, I drew a picture, you have to multiply. I thought number 17, the triangular prism, was hard because you had to multiply, and then you also have to multiply again. But yeah. Like I said, I have all the answers here, so let me know if you have questions. You should have been able to pause that video. You can feel free to join in on some sort of Zoom or something requested if you have questions. But for today, we're going to be dividing polynomials. This lesson is a little bit tricky, but if you take good notes, then you should be able to get a good general understanding of this. And if you don't, then we'll post some Khan Academy videos to help you out. So let's get started. First things first, if you are dividing by a monomial, remember that is a single term, you can do kind of a cool shortcut way of doing this. So right now this says 3x squared plus x minus 6 divided by 3x. I like to rewrite these division problems by a monomial as a fraction. And then when you do that, the cool thing is you can divide each piece by 3x and then you're going to get your answer. So if I have 3x squared over 3x, and then I'll have a plus x over 3x, and then it'll be a minus, because that minus sign here, minus 6 over 3x. And now what we're going to do is just try to reduce our fractions. So here, 3 divided by 3 is 1, and then if I take an x off the bottom and the top, I'm left with 1 on the top. This next one, my x's cancel, so all I'm left with here is a 1/3. Remember that 3's on the bottom, so you have to put that placeholder of a 1 on the top. And then this last term, it looks like the only thing I can do is reduce 6 over 3 to become 2 over 1, so then I'll get 2 over x. So like I said, dividing by a monomial, you take each piece of the original polynomial and divide it by that monomial that we're given, and then you're just going to be reducing those fractions. So let's practice that one more time. Let's see here. Let's do number 3. So we have y cubed minus 4y squared plus 9y divided by 4y. And if we're going to take each individual piece and divide it by 4y, so it should be minus, apologies, this should be a minus sign, 4y squared over 4y, and then plus 9y over 4y. Remember, once you divide each piece by that monomial, we can reduce our fractions. I have a y on the bottom, and I can take 1 off the top to get 2 y's left on the top. This next one, I see 4 divided by 4 would cancel, and if I were to take a y off the top and the bottom, I would just be left with 1 y on the top. And then this last term, I have y's that would cancel, and then 9 over 4 cannot be reduced. You could convert that to 2 1/4 if you would like, but that's up to you. That's your preference. Okay, so dividing by a monomial, you take each piece and divide each piece individually by a monomial. It is different than when we divide by a binomial. So I would separate your notes into two sections here. When you are dividing by a binomial, you have to set this up like long division. So we're going to take our binomial here, the m plus 1, and say how many times does that go into m squared plus 4m plus 3. So remember, if you were doing original long division, if I were to say like what's 29 divided by 3, you would have to say, actually let's do 39 divided by 3. You would have to say how many times does 3 go into 39, right? And then you want 3 times what gives me 3, and you'd put that up here. A similar concept, m times what would give me m squared? Well, m times m would give me m squared. So once again, my goal is for these first terms to match. I want to get them to match. In order to do that, m times m would give me m squared, but m times m is m squared. I also need to multiply that m by 1. So I'm going to get m squared plus m when I distribute this factor up here. And then I have to subtract. So just like if we were to do long division, remember 3 times 1 is 3, and then I would have to subtract to get 0. And then I would drop down my next term. Similar concept here applies. M squared minus m squared is 0. 4 minus 1 gives me a 3m. Whoops. And then I'm going to drop down that plus 3, and we're going to repeat this process again. M times what would give me 3m? Well, m times a positive 3 would give me 3m. So when I get a 3 up here, I'll do 3 times m is 3m, but then I also have to worry about that second term. 1 times 3 is 3, and then when I subtract, you should see 3m minus 3m is 0, 3 minus 3 is 0. This stuff on top represents my final answer. I know this is really complicated. We're going to go through a few examples. So let's try one more. And the first thing I want you to do is make sure you are in standard form first. It looks like this divisor, this y squared minus 7y plus 2 was out of order. And if we're dividing that by y minus 3, that's what goes on the outside. Okay. With long division, you have to think y times what would give me y squared? Well, y times y would give me y squared, right? So when I put a y up here, I have to give the y times y to get y squared, but then I also have to do y times negative 3. And when I do this, I have to subtract both terms. Y squared minus y squared is 0. That's a good thing. Negative 7 minus negative 3. Remember, minus negative turns to a plus, right? So negative 7 plus 3 would give me a negative 4y, and then I have to drop down my next term. Once you've dropped down your next term, the same process applies. My goal is to get the y and the negative 4y to match. So y times negative 4 would give me negative 4y. But when I give the y the negative 4, I also have to do negative 4 times negative 3 is a positive 12. And then I'm going to subtract. Negative 4y minus negative 4y, well, that would give me 0, right? Negative, this would turn to a plus. 2 minus 12 would give me negative 10. There's nothing left to drop down, and there's not much left to do. So if you recall from a question like up here, if I were to do like 38 divided by 3, we would have 3 goes into 38 once, drop down your 8, right? And 3 goes into 8 twice, so minus 6. My remainder was 2. If you guys remember, we had to take our remainder and divide it by our quotient. The same thing happens with polynomials. We take our remainder and divide it by our quotient, y minus 3. So that final answer should be y minus 4 minus 10 over y plus 3. Really complicated stuff, right? Remember, the goal is to get these first terms to match, so y times what would give me y squared. That's how I'm coming up with these numbers up here. The tricky part is remembering to give the y to both terms before you subtract, and then to continue the process by dropping down the next number and getting your first terms to match again. So let's continue that process with a few more examples. So let's do this one right here. We have s squared minus 3s minus 28 divided by s minus 7. How do I get these first terms to match? Well, s times s would give me s squared. So s times s is s squared, but then s times negative 7 is negative 7s. Once I have both terms written down, I can subtract to see s squared minus s squared is 0. Negative 3 minus negative 7 would turn this to a plus. Negative 3 plus 7 is a positive 4s. And then to continue my process, I drop down the 28 and start all over again. How do I get these first terms to match? Right now, this s is missing a 4, so I'm going to give it a positive 4. And when I give the s a positive 4, I also have to give the 7 a positive 4. Negative 7 times 4 is negative 28. So when I subtract, 4s minus 4s is 0. Negative 28 minus negative 28, remember that would turn to a plus, would give me 0. So my final answer is going to be s plus 4, and it looks like there is no remainder. Okay, one last example, and then we'll let you guys try this. I know it's not easy, but let's try this example. It says find 3q squared minus 8 divided by q minus 2. So that q minus 2 would have to be on the outside, but do you see how it goes straight from 3q squared all the way to a minus 8? Your missing term, it looks like it's missing x to the first power, right? Or in this case, q to the first power. Sorry about that. If you have a problem and it skips immediately from the second degree to the 0th degree, you need to fill in the missing term with that missing degree. So I'm going to fill in, I have 0x to the first powers. Once you fill that stuff in, we're going to continue this process just like we were doing before. How do I get these first terms to match? Well, it looks like this term has a 3 that we're missing, and it looks like we need to give it another q, right? 3q times q would become 3q squared. But 3q times negative 2 is negative 6q. And then once I have distributed that 3q, I have to subtract 3q squared minus 3q squared is 0. 0 minus negative 6, remember that would turn to a plus 6. I'd get a positive 6q. And then I can drop down my next term and repeat this process. So my goal is to get the q and the 6q to match. So it looks like I'm missing a 6. If I give the 6 to the q, whoops, I also have to give that 6 to the negative 2, which would give me negative 12. When I subtract, I would get 6q minus 6q, which is 0. Negative 8 minus negative 12, remember that turns to a plus. Negative 8 plus 12 is a positive 4. I have a remainder, it looks like, because there's nothing left to drop down. When that happens, I take my entire statement, and then I have my remainder, which is 4, divided by my quotient, which is q minus 2. This is really, really tough stuff, but remember, you want your first terms to match, so whatever this quotient is missing is what you put up here, and that's what you're going to give to both terms in order to subtract and continue the process, right? Okay, I wish you the best of luck. On your homework, please email if you have questions, request a Zoom, try the Khan Academy videos that we're going to post.